We are starting Unit 3 today, talking about quadrilaterals and polygons. And for our Do Now activity, we did a little arts and crafts. So I'm going to do this in front of everybody. We're just cutting out the shape along the red dotted lines, and then we're separating the 4 angles. So let's see how quickly I can do that. Oh, gotta cut these. Okay, so then after cutting out the shapes, arrange them so that each angle shares a line, or not a line, shares a vertex, and the red dotted lines are up against each other. So let's do that. Here's the red line. A, B, C. Okie dokie. Perfect, but
One looks a little different, but they all still touch it.
you put yours just in a different order, maybe?
The B is upside down.
Ah.
The A still touches the D, the B still touches the A. It's just a little differently. The D and B have switched.
Slightly different orientation. Okay, and then I'm gonna take mine. I forgot to grab a glue stick. There we go. Okay, so here's my shape. So we followed the directions on the activity sheet. Now we're gonna answer the questions. So that original shape, how many sides did it have?
4.
4. Perfect. And then how many angles did that original shape have?
4.
Also 4. And now here's the tricky question, and we kind of talked about it before I started videoing, but we'll talk about it again. What do you think the sum of the shape's angle measures is? So angle A plus angle B plus angle C plus angle D, about how many degrees would they create all together?
360.
360. So how'd you figure that out? How'd you know it was about 360?
Because JJ had 4 angles, it does a full circle.
Yeah, we can see that these angles, they all line up against each other and create a circle, just like that. So I'm gonna write here, the sum is 360 degrees. Oh, here, I'll get rid of that. There we go. Perfect. Okay, so this is just like that triangle discovery where we figured out that all 3 angles of a triangle add up to 180 degrees. Now we know that all 4 angles of a 4-sided shape with 4 angles is 360 degrees. It's twice as much. So that's going to lead us into our next unit here, Unit 3. So we're going to start a new page of notes. And get out my notebook.
This still have a whole lot of room in this. It takes a lot of turning when you turn one page by another because sometimes they like to stick.
Yes.
Especially when my notebook got soaking wet once, so the pages are a little different. they were like brand new and all the wet.
Right. Okay, so I'm gonna title my page Geometry Unit 3. And I'm also gonna write day 19 continue, just so I can keep track. This is page 2. We're doing that.
On the last month of this term,
It's crazy. This is just flown by.
which means it's only 3 weeks.
Nuts. Can't even think about it.
So we're over 3/4 of the way now. So crazy.
Okay. We're gonna title this Quadrilaterals. So quad, ril, R-I-L-A-T-E, quadrilateral.
Do you remember how to spell that?
Well, I'm cheating. I wrote it down here and I'm copying it.
Nice.
So I know that it's quad, then and then lateral.
Not confusing.
It is. It is a
Big
little
word.
It is a large word. So there are a couple of things that we can use to identify. Let me pull this up. Use to identify a quadrilateral. So a quadrilateral is a shape that has 4 sides. Let's write that down. 4 sides, has 4 vertices, the vertex, and has 4 angles. And a quadrilateral, their angles add up to 360 degrees.
I'm writing the right letters just in the wrong places.
All right. It's funny, I kind of do the same thing sometimes. I was trying to write Monday on my notes last night, and I started writing a P. For what reason, I don't know. And then I was like, okay, well, let me just go over here and write page 1. And then I wrote the A first. It was so odd. Hello, Alexis. What's up, girl?
Another practice paper.
Yeah.
All right.
No, you're good. We paused.
The
I
line.
know. I'm
Not
supposed
the
to hit
square.
pause. Oh well, we're back. Okay, so
Somehow you're supposed to have to be able to combine the video and then tamper with it.
I know it. So a quadrilateral can be any 4-sided shape. It can look as funky as you want it to. A square could be a quadrilateral, like that. A shape like this could be a quadrilateral. That's got 4 sides and 4 angles. Let's see. That's quadrilateral. Basically anything with 4 straight lines making sides that connect to 4 vertices and have 4 angles. Quad means 4. So that's kind of a big idea there. So let's talk about a couple of different types of quadrilaterals. The first one that I'm going to have us talk about is called parallelogram.
What?
A parallelogram. You ever heard of that before? So it's P-A-R-A. Make sure I'm spelling it right before I write it down. Yes, P-A-R-A-L-L-E-L. So it's the word parallel. O-gram.
Does that mean it's like lines up with something?
Kind of. So do you remember what parallel means?
2 lines that go side by side, never touching.
Yes, 2 lines going side by side that never touch. So a parallelogram is a type of quadrilateral. So we know it's got four sides. We know it's got four angles, four vertices. But there's a couple of things that we have to know about parallelograms. And here's the rules. So first of all, it's opposite sides. Draw a picture of one in a moment here. Opposite sides are parallel. And they are equal. They're the same length. Then opposite angles are equal.
And they're congruent, which means they're equal.
Yes, exactly. So the opposite angles are congruent. Opposite angles are equal. Then consecutive angles, and I'll explain what that is too. Consecutive angles are supplementary. Do you remember what that word means?
So equal to 180.
Yes, supplementary. So they add up to 180. Last but not least, diagonals bisect each other. Okay. So we're going to draw a picture of parallelogram here once you get done writing those four fires.
Does it have to be all of those?
Yes. If it doesn't meet any of these requirements, it's not a parallelogram. And you just let me know when you finish writing those. Take your time though. Okay, so now we're going to draw a picture of one. So we're going to start, let me pull this out a little. We're going to start by drawing a line that is, let's go with the 2 inches. No, let's do 3 inches. Going straight across here. 2, 3, there we go. Okay, now the next line, we're going to make it tilted like this. And I'm going to make this one 2 inches. Now the key is to make sure that the next side that we do is the same angle over here. So it might not be perfect, but try to get your ruler to stay about the same angle when you draw this next side. And it should also be 2 inches. I should have lined my ruler up. Let's see. 2.
And then you connect the two.
Yes. Okay, let's see. It's gonna have to be close enough.
Is it perfect or can you?
It's okay if it's not perfect. Mine definitely isn't.
I tried.
Close enough. That looks pretty good. Okay, so let's label all these 4 things. So I'm going to use colors for this, and I'll use my colorful pen. Got the same one as you. Let's see. So first, let's label the opposite sides that are parallel to each other. and equal to each other. So the opposite sides are the ones that are just across from each other. So we'll start with labeling the two sides here. Since they're parallel, we draw that little arrow. And then since these are parallel, we draw the arrow again, but this time we put two arrows to show that it's parallel to a different line, just like how we would do different numbers of arcs or dashes. Okay, so that shows that they are parallel. Now, do you remember how we label when side lengths are equal?
The dash.
Yes, the dash. So we're going to put one dash here, one dash here, and then two dashes on the other one. So that shows that they are parallel and equal. So now we're looking at the opposite angles. I'm going to use purple for the next one. So what angles would be opposite to each other? Maybe we should label them. I'm going to call A, B, C, and D. Which angles are equal to each other?
C.
Yes, A and C, they're opposite. So we're going to draw an arc on A and an arc on C. What other angles are equal?
B and D.
B and D. Now, how do we label those differently?
Two arcs.
Yes, with two arcs. Perfect. Okay. Now, let's use, what color you want to use next? A lot of options.
Blue.
Yes, blue. Okay. So now we want to talk about consecutive angles being supplementary. So consecutive angles just means that as we go around the angles, like going from A to B to C to D, or A to D to C to B, all the way back around, consecutive angles are just the ones that come one after another. So I could say angle A and angle B are consecutive. So A and B are supplementary, or I can add them up to 180 degrees. So let's write that. I'm going to write angle A plus angle B equals 180 degrees. I could also say that angle B and angle C add together to make 180 degrees. So let's write that. Angle B plus angle C equals 180 degrees. What other consecutive angles could I name here?
Angle C and angle D.
Perfect. Angle C plus angle D equals 180 degrees. And there's one last pair. Perfect. Angle D plus angle A equals 180 degrees. Beautiful. And what color should we use for the last one? Orange, purple, blue.
We've already used purple. We've already
Yes.
used blue.
So we've got red and green left.
They're not red.
Red?
Yeah.
Let's do red. Okay, so now diagonals bisect each other. So A diagonal is exactly what it sounds like. It's a line that goes diagonal from one angle or one vertex to another. So to create diagonals in a parallelogram, we take our ruler and we line up on the vertex of each opposite angle and draw. That's one diagonal. And we just draw the other with the other opposite angles. Okay. Now, what did you say? Yes, it does create an X. They're going to cross right in the middle. Now, is this a perpendicular bisector?
No, because they
No, it's not perpendicular. Oh, you're thinking of parallel. So remember the perpendicular bisector is whenever it creates a 90-degree angle, right? So a bisector is something that cuts something in half, meaning these diagonals cut each other in half. So this section of the line is the same length as this section. And I guess I shouldn't use 2 lines because we already used 2. Let's do 3. And then what other lines that we've created are equal?
to that cross to A and C.
Yeah, exactly. So we're going to put 4 dashes here because we've already done 1, 2, and 3. Beautiful. So we can use these facts to solve for lots of different things. For example, if I gave you the measure of just one angle in a parallelogram, for example, let's say I'm going to give you a problem. So let's say I give you, given is that angle A is 60 degrees. Could you then find the measure of angle B, angle C, and angle D?
Like this first angle A and angle C was equal to them being across from each other.
Yeah, angle A and C are the same since they're opposite. So we could go ahead and label angle C as also being 60 degrees. How would we find the rest?
We could use the finding a 90-degree angle, which is up on the little side.
Perfect. So let's come up with an equation. Do you want to solve for B or D?
B.
B. Okay. So how could we solve for B?
We have angle A, so you can do 60 plus
Mm-hmm.
B equals 180.
Perfect. 60 plus B equals 180, and we just solve for B. So we'll subtract 60 from both sides. That's going to give us B equals what? 120. Beautiful. So that's going to be our measure for angle B. And boy, 120 degrees. And what would the measure of angle D be? Also 120 degrees. Perfect. Perfect, perfect. Hey, that's not so hard. That's kind of like review, just with a different shape. Beautiful. Okay, let's go to the next page. So now we're going to talk about types of parallelograms. Oh my gosh, there are lots of types. So I'm going to start a new page and I'm going to label this again. Geometry Unit 3. This is page 3 of our notes. And building. So parallelograms are types of quadrilaterals. They've got 4 sides, 4 vertices, 4 angles. But within the category of parallelograms, there are subcategories or smaller, more specific versions of parallelograms. So I'm going to write up here types of parallelograms.
When you do 2 hours when it's just one.
I have trouble with words like that where there's a bunch of different letters that want to be repeated. I have problems with the word occurring. I'm like, is it 2 C's? Is it 1 C? Is it 2 R's? Okay,
I'll mix up my B's and D's and
I feel ya. I do the same thing.
It's infinity signs every once in a while, and I don't get why when they're facing 2 different spots.
Okay, so types of parallelograms. We have a rectangle. Rectangles follow all the parallelogram rules. But to be more specific, rectangles also have to have all angles are 90 degrees. So if you don't have 90 degrees for one of your angles, you don't have a rectangle. And the second rule is that diagonals are equal. So with the first picture we drew with parallelogram, we got diagonals, but they're not the same length as each other. A to C is a little longer than B to D. But with a rectangle, the diagonals will be equal. So let's draw a little mini rectangle over to the side here. I'm gonna make, yeah, I'm gonna make 2 centimeters my height. And I'm gonna go with 4 centimeters as my width. Make sure that all our angles are just about 90 degrees. So,
So hard, simple, tiny.
I know, sometimes just getting the drawings done is the toughest part.
That is not right. They're all 90 degrees. I can tell that. They just
Yeah.
look a little.
Wonky.
Yes.
That's okay. All right. Let's label all our 90-degree angles. I'm also going to say one more thing that makes the rectangle a rectangle is that we have, let's see, I'm trying to think of how to describe this, where you have one set of congruent sides and another set of congruent sides, but they're not the same length as each other. Opposite sides are congruent. Let's say that. Opposite sides are equal.
Is it even if it's opposite sides?
Yes.
Those opposite sides back, but not all. Now a square, they would all.
Yes, that's right. The square is one of them that we'll talk about today.
Is it like a rectangle, two squares together?
It could be, but not always.
It just depends on the side. When I think of a square, I say a rectangle cut in half.
Pretty close to that. It basically is. It just depends on the length of your rectangle. Because if I had a super long, skinny rectangle and I cut that in half, I would then have two rectangles. They don't always become squares unless it's the perfect length that when you cut it in half, all four sides are the same.
Or sometimes if I look at real big rectangles or something, I'll try to divide it into little pieces so it feels like squares.
Right, that's smart.
I don't know why that's like a little obvious.
That's all right. Okay, and then let's label, well, here, let's see. I guess I'll pick some colors again. Let's do purple for the diagonals. Cool. Draw our diagonal.
These things confuse me. The blue, the color of the outside of the thing is light blue. So
Right, and then it's like such a dark.
But then once you draw with it, it's pure darkness.
I know. I was thinking the same thing.
And it's just like, oh, come on.
Right.
I'm glad that it's seeable, but it's light blue.
And then I'm going to label my edges or my vertices A, B, C, D. And to show that these are equal, since they cross over each other, it's kind of tough to show that I'm talking about the whole line or the whole diagonal. So we're going to write some statements to show that the diagonals are equal. I'm going to say that AC, that line AC, so we'll write AC with a line over it. Congruent symbol to either BB or DB. Either way, doesn't matter. We'll go with BB. So since our diagonals are equal, AC is congruent to BB. Perfect. And then we need to label our opposite sides as equal. So I'm going to use orange for this one. And here's where we'll use those dashes or the tick marks. So I'm going to label side AD with 1 and BC with 1. And then I'll do AB and DC with 2, like this. Beautiful. Now, we probably aren't going to do many angle problems with rectangles because they're all 90 degrees. So it won't be too tough to solve for them. But it's just good to know what a rectangle is so we can classify it. Okay, next type of parallelogram is a rhombus. Yes.
Isn't that like a square just facing a certain way?
Yeah, it's like a tilted square or like kind of like a diamond, similar to a diamond. H-O-M-B-U-S. Rhombus. Wonder who named it. Such an odd name.
I have no idea.
It's
It's confusing.
I know.
Like the names are at least.
Right. So here are the qualifications for a rhombus. First of all, all four sides are going to be equal. So all four sides are equal. And the diagonals are perpendicular. What does perpendicular mean again? Yeah, it's not parallel. Parallel is where they're side by side.
But it perpendicular ones that actually cross.
They do cross, yes. They cross at a certain angle. For it to be perpendicular, do you remember what the
90 degrees.
Yes, perpendicular. So that means those diagonals right here are going to create 490-degree angles in the middle if it's a rhombus. So once we've got that written out, let's draw a rhombus. I'm going to make this, let's go with 3 centimeters. I'm going to make it kind of tilted here. So 1, 2, 3. Make my next side also 3 centimeters. And the rest of the sides need to be 3 centimeters as well, which I guess I picked a pretty good length because it's just about the perfect width of the ruler. So I can line it up pretty well. 2, 3. Yeah.
Have to realign this one.
It's enough, I think. So there's my rhombus.
Can't even remember how
Lots of drawing today.
It also is helpful that this thing goes off the page and I'm on a spiral notebook.
The spiral notebooks are not fun to write on the edges. Okay.
Okay, writing on, but not when you have to do it with a ruler.
True. Very true. So let's label our 4 equal sides.
Okay, I tried.
I'm sure it's great. So all 4 sides are equal. So we need to put the same number of tick marks on every single side. So we're just going to put 1. 1, 1, 1. Cool. And this is also just like a parallelogram. Our opposite angles are going to be equal. Our diagonals are going to bisect each other. Everything's going to be just the same. The only other qualifying factor is that these diagonals, if we did it correctly, should be perfectly making that 90-degree angle. So let's try that. We get purple again. So diagonals.
Mine probably may not be doing that correctly because
We'll see. If you made them pretty close to the same length, it should be pretty close to 90.
Made them the same length. It's just may not align exactly.
That's all right. There's one diagonal. Pretty good. And that's perpendicular to me, so I'm gonna put a little box in there.
And you're trying to cut into the paper. I need you to draw, not cut into the paper.
I'll tell you what else I noticed. Looks like the diagonals are also bisecting each of the angles, cutting them in half perfectly. What it looks like to me.
I believe I did it.
You'll have to tell me how your picture turned out. How's it look?
Yes.
Look pretty perpendicular? Yeah, that actually looks really good. Nice. Very nice. Okay, and last parallelogram we'll talk about is a square. One we all know. Here's
All of these square fits in a.
say it one more time.
With all of these, a square fits in a.
Yes. Well, what do you mean? Fits in what?
Like in the rectangle, it fits in that. The little angles are squares themselves. And then you can split it into squares.
Okay, so like the square is the most specific type of parallelogram, but a square also meets these requirements. Is that what you're saying? You are correct. Absolutely. Square is the most specific, but we could also say that a square is a rhombus. A square is also a rectangle. A square is a parallelogram. Pretty cool. So a square has to have all the properties of a rectangle and a rhombus. So a square is like these two when they have a baby, they make a square. So all the angles are 90.
First, you had to bring up Dan.
Yes.
That's just the door.
All angles are 90 degrees and all four sides are equal. Properties, rectangle, and rhombus. So squares are just the most specific version of those two. All right, now we're going to draw a square. The last one we draw. I'm gonna make it 3 centimeters, just like I did the rhombus. Square won't be perfect, but it'll be good.
It'll be something.
It'll be something. All right, there we go.
This is the last, but
The last parallelogram. So I'm gonna label this as well. I think we used green for walls. And then 4 sides are equal. Here's the orange. And it's wonderful. Okay, so let's see. We've actually got, let's just worry about these for now. Worry about these. Okay, so we have parallelograms. We've got quadrilaterals. Every shape we talked about today is a quadrilateral. They all have 4 sides. They all have 4 angles. They all got 4 vertices. And all the angles are always going to add up to 360 degrees. Now, let's see. I think that's all I want to have you put on those notes today. Trying to decide. I might go ahead and give you your exit ticket. Let's come up with a good one. We just get through things so quickly.
So this is our first day back.
Yes.
It's a Monday.
Yes, it is. So.
And I did not get sleep.
You didn't get sleep.
I looked it out. I had trouble falling asleep. I eventually fell asleep.
Well,
But
good.
my dog decided to be a pain in the butt.
Oh no.
And he wake me up at 4 in the morning, bust his head off.
Oh my goodness.
So I had to calm him down, force him to lay down until he'd stop going crazy. So that he wouldn't wake up my aunts and cousin and all of them.
I swear, that's how my cat is.
And he's normally not like that. Also, at Dad's he doesn't bark as much as at Aunt Nikki's.
Really?
Yeah. And then I finally fell asleep.
Well,
Like
good.
6, and then I had to wake up at 7.
And write the due date on here. I'm gonna start doing that. It's due 1 week from now, so due Monday. Excuse me, December 9th. So I am going to give you a parallelogram. I'm not going to worry so much about the length of the sides just yet because I'm going to give you different lengths. And if you want, Ella, I can make a copy of this for you if you don't want to have to write it out because I'm going to make copies for my other class.
Please do.
Absolutely, girl.
And I don't have to use this paper.
Yes.
That would be nice because that means I'd have to draw it all and I don't feel like doing it.
Yep. Okay, let's see. This was.
I don't really feel extremely stressed or something, but that's because I have sugar in my system.
Yes, that's what that sugar and that caffeine will do.
I'm like making me extremely hyper. So if due to my ADHD, it calms me down.
That's funny. It kind of does the same thing to me too.
Due to a lot of people that have ADHD, it causes opposite effects.
Yes. Okay, that's gonna be close enough. And here, I'll pause this while I'm working on my. Okay, so here's the exit ticket. I've given you a parallelogram A, B, C, D. I've told you angle A is 72 degrees. From A to B, the length is 5 inches. From B to C, the length is 7 inches. And you need to find all of these measures using your parallelogram properties we talked about today in our notes. All right, I'm going to end this video and make copies.